Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 14, where we will again solve a problem based on hashing, and the level of this question is going to be medium. The name of this question is top k frequent elements. You will get this question link in description, and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on LeetCode. So this is our question on LeetCode. It says, given an integer array nums and an integer k, right? Return the k most frequent elements. You may return the answer in any particular order. So question is very simple. Question says that we have given an integer array named as nums and an integer variable named as k. Now we have to return k most frequent elements, right? And we can return our answer in any order, right? We can return our answer in any order. So now let's analyze what does they mean by k most frequent elements. So let's take some examples. So let's say this is our nums array and this is the value of k, right? And we have to return k most frequent elements. Okay, so when they say we have to return most frequent element, right? Most frequent element, they mean we have to return an element whose frequency is higher, or you can say whose frequency is maximum. So you can say that we have to return two elements with the maximum frequency, right? We have to return the two elements who have the maximum frequency, right? Who have the maximum frequency in this array. So let's say this is our array and these are our indexes, right? So firstly, let's write which number is occurring how many times into our array, right? So firstly, if we talk about this 1, we can clearly see this 1 is appearing 3 times, right? This is number 1, number 2 and number 3. So I can clearly write that 1 is appearing 3 times in my array, right? Similarly, if I talk about 2, then we can clearly see 2 is appearing twice, right? This is number 1 at index number 3 and number 2 at index number 4. So I can write that 2 is appearing twice into my array, right? Similarly, if we talk about 5, right? Sorry, if we talk about 3, then we can also see that 3 is appearing only once into our array. So I can directly write 3 is appearing only once into my array. Now after this, after doing this, what we have to do? See, here it is mentioned that k is equal to 2. It means that we have to return two numbers, right? It means we have to return two numbers or two elements from this nums array, right? With the most frequent means with the maximum frequency. So here we can clearly see that 1 have the maximum frequency, which is equal to 3, right? 1 is appearing 3 times into my array. So we can say that 1 is the most frequent element, right? So I will write 1 here, right? I will write 1. After writing this one, I still have to return one more element because k is equal to 2. It means that I have to return two elements. Now let's think of if we just ignore 1 after 1, which is the second element which is most frequent, right? After removing 1, right? So we have seen that 1 was appearing thrice, right? 1 was appearing 3 times. If I just ignore this one, or if I just remove this one, and if I again ask you, just give me one element with the maximum frequency, then what you will return? Yes, you will return 2, because 2 is an element which is appearing twice, right? It is maximum frequency. With the maximum frequency, if we just remove or ignore this one, right? So now I will write 2 here, right? And after this, I will just simply return this thing, right? I will just simply return this array or this vector with 1 and 2. So this was our question, right? The question says that we have to return k number of elements with the maximum frequency, or question says that we have to return k most frequent elements, right? So what does they mean by k most frequent? They mean by maximum frequency. So we have to return k elements who have the maximum frequency, right? So I hope this is clear. Now let's think of how we are going to solve this problem. So while I was explaining this particular question, I was using something known as frequency, right? I was using something known as frequency. It means that I was just storing which number or which element is appearing how many times, right? Which element or which number is appearing how many times in my array, right? And which data structure, with the help of which data structure we can easily store these two values, that is the number or the element and how many times it is appearing. Yes, you guessed it right. We have to use map or hash map, right? We have to use map or hash map. Now, if I use map or hash map, then we can probably store the element and its frequency, right? So let's say I am using one map named as MP, where I am storing two things. First is the element and second is its frequency, right? How many times the particular element is present into my array, right? And I just need to do a normal traversal. So let's say my eye is pointing here at 0 initially. So here I see that I have 1, right? I have 1. So what I'll do, I'll write, okay, 1 is appearing once, right? Then I will just increment my eye. So I will come at index number 1. Again, I will see which element is present. You will say 1 here, right? So I will just increase the frequency of 1 this time, right? So instead of 1, I'll write 2. Okay, it means that 1 is appearing twice up to this particular index, right? Now what I'll do, now I will again increment my eye. So now my eye will point at index number 2, right? Here also the element is 1 itself. Then again, I will increase the frequency of 1 and it will become 3, right? It means that up to this particular index, up to index number 2, the element 1 is appearing 3 times, right? The element 1 is appearing 3 times. Okay, after this, I will again increment my eye. So now my eye will point at index number 2, index number 3, and the element present at index number 3 is nothing but 2, right? So we have seen this 2 for the first time, right? So I can say that 2 is appearing 1 time up to this point, right? Up to this particular index, right? And after doing this, what we will do, we will again increment the value of I. So now my I will point at index number 4 and the element present at index number 4 is again 2, right? So we will again increment the frequency of 2 into our map. Now instead of 1, we will write 2 because we can clearly see 2 is appearing twice, right? 2 is appearing twice into this array up to this particular index. After doing this, we will again increment our index. We will again increment our I pointer, or you can say I variable. So now my I is pointing at index number 5, right? It is pointing at index number 5 and the element present at index number 5 is nothing but 3. We can clearly see that 3 is appearing one number of time, right? We have seen this 3 for the first time. So we will directly write 3 and 1, right? 3 and 1. It means that up to this particular index, we have seen this 3 for first time, right? We have seen this 3 for the first time. And after that, what we will do, we will again increment the value of I. So now my I will go out of bound and you can say our loop will get terminated, right? Our loop will get terminated. Okay. Now after this, what do we want? After this, what do we want? We have to return k number of elements, right? We have to return k number of elements and the k number of elements with the maximum frequencies, right? With the maximum frequencies. So here you can see that, the map is already sorted in terms of frequency, right? The map is already sorted in terms of frequency, right? Here we have 3, then we have 2, then we have 1. So you can say that the frequency is already sorted in decreasing order, right? The frequency is already sorted in decreasing order. But it's not important that when we are using a map, or even if we use an unordered map, then it is not important that every time our frequency will definitely be in any particular sorted order, right? It can be random. So we have to make sure that our frequency is sorted, right? We have to make sure that our frequency is sorted. So let me just give you an example if you are getting confused. So let me just change the values. Okay, so let's say we have 2, 2, 3, 1, 1 and 1 into our nums array. And if we again traverse into our nums array, we'll get the same thing, right? We'll get this same thing. Now the elements, like the elements can be in any specific order, so we do not have to do anything with that, right? But what we want our frequency to be in sorted, right? We want our frequency to be in descending order, so that we can take the k number of most frequent elements. So how we can do that? Can I directly sort my map data structure? So the answer is no, we cannot sort our map data structure. So what I'll do, I will just store this element and frequency into a vector, right? Into a vector of pair, right? I will use a vector of pair and I will store it. I'll store it, right, in that particular vector. So let's say I have one vector, right? I have one vector which is storing some pairs, right? Which is storing some pairs. So what it will store? It will store 1 and 3, right? It can store 1 and 3, and it will store 2 and 2 because 2 and 2 signifies that the element 2 is appearing twice, and then it will store this 3 and 1, 3 and 1. Okay. Now what do we want? We want our frequency to be in sorted order, right? We want our frequency to be in sorted order. Now if I directly sort it, if I directly sort this particular vector, then the sorting will be done on the base of this first element, which is this 1, which is this 2, and which is this 3, right? And this is what? The first element is what? It is our element which is present into our array, right? But what we want to sort this particular vector in terms of frequency, right? And where is our frequency? Frequency is here at the second point, right? Here is at the second point. So we want to sort this particular vector in terms of our frequency, So what we will do, see, in our vector at this point, what we are storing our element and the frequency of that particular element, right? And when we are performing the sort operation, then sorting is being done on the basis of this element, right? So if we want to sort our vector in terms of frequency, what we can simply do, we can store element in this way, right? I can store frequency first and then the element, right? And now if I do the sort method, if I call the sort method, then the sorting will be done in terms of frequency, right? Then the sorting will be done in terms of frequency. So I hope up to this point everything is clear. So what we will do, we will store elements into our vector in terms of firstly frequency and then element, right? So I will firstly store this 3 and 1, right? Then I'll store 2 and 2. Then I'll store this 3 and 1. Sorry, not 3 and 1. I'll store 1 and 3, right? 1 and 3. Now what I want to sort it in terms of what? In terms of this frequency, right? In terms of this frequency. So I can just directly call the inbuilt sort method. Of C++ STL. So what it will do, it will sort it in ascending order, right? It will sort it in ascending order. So after performing the sort operation, my vector will look something like this, right? My vector will look something like this, right? Something like this. Okay. And here this is nothing but our frequency, and this is nothing but our element, right? This is nothing but our element. Now what we want k most frequent elements. Basically means that we want k elements with the maximum frequency. It is in the, what is it? It is in the sorted order. It is in the ascending order. So from where I'll get the maximum? I'll get the maximum from the back, right? I will get the maximum from the back. So I will just do a traversal from the back. I will do a traversal from the back of my vector. And now I will take this 1 because I know the element is present at here at the second position. So I'll take this 1 and then I'll take this 2. And only take these 2 elements because in the question it was clearly mentioned that we have to return only k most frequent elements, right? So I hope this particular approach is clear. This is the brute force. This is very easy. So I hope you have understood this. And if you have any question, just kindly do some dry runs by taking some more examples. Then this particular approach will become crystal and clear into your mind. So now let's think of how we are going to code this particular problem. Okay, so now let's think of how we are going to code the approach which we have just discussed. So in that particular approach, what we needed, firstly, we needed one unordered map, right? We needed one unordered map to store the element and the frequency, right? So therefore, I have just declared one unordered map with the two values. First is the integer, which is going to be my element, and the second is again integer, which is going to be the frequency, right? After that, what we need next, we need one vector, right? We need one vector to just return our answer, to store our answer. Therefore, I will just declare one more vector and I will name it as answer, right? I will name it as answer. So what was the first step? Firstly, we need to traverse into this nums array, and we need to store the element and the respective frequency, right? So how we will do that? It's very simple. We will just write one normal for loop. I is equal to 0. It will go up to n, where n is nothing but the size of our nums array. And here we will write mp of nums of I plus plus, right? So now all the elements and their respective frequency will be stored into our map, right? Now after storing our frequency and elements into our map, what do we need? We need to transfer our data from map data structure to a vector of pairs, right? So for that, let me just declare one vector of pair which will store two integer values, and let me just name it as LE freq. It is nothing but the element frequency, right? It is just a short form for element and frequency, right? So now I will just write a for loop for auto it, which belongs to mp. Mp is nothing but our map, and we want to store our data into our element frequency vector, right? So here I will write element frequency dot push back, right? Dot push back. So I want to push a vector, therefore I will use this curly brackets, right? And now I want to push data into my element frequency vector, but in a reverse order, kind of. Firstly I need the frequency, right? Firstly I need to send the frequency, and then I need to store the element, right? So see, into my map, my map was initially like something like this, right? It was something like this, okay, where this first thing, this is first, and you can say this is kind of your second element, and this first element is nothing but the element, but the actual element, and this second is nothing but our frequency, right? Second is nothing but our frequency. So we want to store them into pair, where firstly I want the frequency. That means firstly I need this second element, right? How I will get the second element? I can just simply write it dot second, right? And to get the first element, I'll just simply write it dot first, right? It dot first, and here I'll use one comma, right? So I hope this is clear. I hope this is clear. So now all the element, like all the elements and their frequency which were present into our map are now transferred into our element frequency vector, right? Now what's the third step? Third step is again very simple. We just need to sort. So I will just use the inbuilt STL function in C++, and I will sort our vector. So now this sort method will sort it into ascending order, right? It will sort it into an ascending order. So we can say that our final output will be something like this into our vector, right? We'll have something like this, correct? And yeah, something like this. So it is in what? It is in ascending order, right? Firstly, what we are having, these are our frequency and these are our elements, right? And what I want the most frequent element. Most frequent element means the elements with the highest frequency, right? So you can see that the highest frequency is starting from the end, right? It is starting from the end. So how I will do that? I'll write int index, and this index will be nothing but the last index of this vector. So how I will get the last index? Very simple. I will write ele frequency dot size, and then I'll do a -1, right? Then I'll do a -1, then I will get this last index, right? And I will also have one more variable named as count, which will store the counting of number of elements we are storing into our answer vector, right? So here I will write while this count is not equal to k, right? Not equal to k, because what we want exactly k number of elements, right? Therefore I have written while this count is not equal to k, and I'll write answer dot push back the element which is present at this particular index, right? At this particular index. So I will write the name of a vector, which is element frequency of the index, correct? Of the index. So here you can clearly see, we have two things, right? We have two things. Firstly, we have the frequency, and then we have the element. The element is present at the second position, right? The element is present at the second position. Therefore, I will write element frequency at this particular index dot second, right? Now I will get my required element, and after that I will just do this index minus minus, and I will do the count plus plus, right? And after the completion of this while loop, my answer will be stored into my answer vector, so I can directly return my answer, right? So this is our code. It is pretty straightforward and simple. Now let's fastly talk about the time and space complexity. So the time complexity is going to be around O of n log n. Why n log n? Let me explain you. So see, here we are using a for loop, and here the time complexity will be O of n, right? Here again we are traversing into our map, so you can say the time complexity will be again O of n, but here we are using this sort, right? We are using this inbuilt STL sort method. So here the time complexity for this sort method will be n log n, right? Will be n log n, where n is nothing but the size of our nums array, right? Therefore I have said the time complexity is going to be n log n. And if we talk about the space complexity, then what we are using one unordered map, and in the map we are storing all the elements and their respective frequency. So the space complexity will be O of n, right? At max the size of my map will be equal to the number of elements I have into my nums array, right? And after that we are also using one answer vector. So the space complexity for this answer vector will be O of k, right? Because in the answer what we are storing our k topmost frequent elements, right? So at max the size of our answer vector can be O of k, and at max the size of our unordered map can be O of n. So this was the time and space complexity. I hope the approach is clear. How we are going to code it up is also clear into your mind. So now without wasting much time, let's fastly code it up on LeetCode. Okay. So what are leta? Okay, 1, 2, 3, start. So now here we are on LeetCode. So what do I need? I need one vector to store my answer, and I also need one unordered map of integer comma integer. Let me name it as MP, right? And in this map what I am storing two things. Firstly, I am storing the element, and secondly I am storing the frequency, right? I hope it is clear. So as the first step, our first step is to put all the elements and their respective frequency into our map data structure. So for int I is equal to 0, I is lesser than nums dot size and I plus plus, and here I can directly write MP of nums of I plus plus, right? Nums of I plus plus. After that I need to create one vector of pairs, right? So I will do that fastly, and let me just name it as LE freak or element frequency. Now I want to transfer all the data from my map data structure into this element frequency, right? So for that I'll use another for loop for auto it, and it will belong to my map, and here I just need to write LE frequency dot push back. Here I want to push back a pair, therefore I will use this curly brackets, and I will write it dot second and it dot first, right? I hope it is also clear. Then I just need to sort this vector, so I'll write element frequency dot begin and element frequency dot end, right? After sorting, I know the elements are present at the end, right? So I'll get the index, and it will be equal to LE freak dot size -1, and I'll also use one counter which will be initially equal to 0. Then I'll run a while loop while this count is not equal to k, right? I'll just push back my answer. So I'll write answer dot push back le freak of index dot second, right? Because at the second position I have my element, and then I'll do this index minus minus, and then I will do this counter plus plus. So I hope the code is clear. Let me, okay, after doing this I also need to return the answer, right? I hope this is clear to you. Now let me just run it up fastly. Okay, so we have some error at line number 12. So here I need to write this. Let me run it again. Okay, so you can clearly see that all the sample test cases are running fine. Now let me just submit this. So here you can clearly see that this particular approach is accepted, and I have already explained the time and space complexity to you, but this is not the most optimal approach. We have two more optimal approaches, right? One is the better one and the third one is the most optimal approach, and I want to discuss those approaches as well, but I'll not discuss those approaches in this particular video because already the length of this video is around 30 minutes. So I will make one separate video for the other two approaches. So make sure that you watch those two videos or those optimal approach as well. So this was all for this video. I hope this was helpful to you. If it was, make sure that you liked this video and comment down your experience. And if you genuinely want this type of comment regularly, then make sure that you subscribe to this channel. We will meet again tomorrow with a new question.